Have you ever found yourself just dreaming of visiting the past, or maybe getting a sneak peek into the future? It's one of those ideas that's been with us forever, right? But what if I told you that time travel isn't just for science fiction? Today, we're going to dive into the real mind-bending science behind it all.
I mean, seriously, think about it. The idea of witnessing history firsthand, or seeing what the world is like 1,000 years from now, it's just such a powerful thought. It's the engine behind some of our absolute greatest stories.
But what if it's more than a fantasy? You know, the actual laws of physics, they hinted some pretty tantalizing possibilities. So in this explainer, we're going to separate the hard science from the Hollywood fiction and see what's really on the table.
Okay, so before we can even talk about traveling through time, we've got to get our heads around what time even is. And for centuries, we thought we knew. And then a guy named Albert Einstein came along and just completely shattered our whole understanding of it.
This right here is the absolute key that unlocks everything else. Einstein proved that the universe doesn't have one big universal clock ticking away for everybody. Nope. Instead, time is relative. It's flexible. Your personal experience of time can literally be different from someone else's.
So the old way of thinking, the intuitive way, was that time was like this giant river, just flowing at the exact same speed for everyone everywhere. But what Einstein showed us is that we each have our own personal clock, and incredible forces like immense speed and powerful gravity can actually change how fast that clock ticks.
And this radical new idea about time? Well, it opens the door to our very first and most scientifically plausible form of time travel, a one-way ticket straight to the future. And this isn't just a theory, it's based on a proven scientific phenomenon.
The big secret is an effect called time dilation. It's a direct consequence of Einstein's theory of relativity, and it is our honest-to-goodness, scientifically backed ticket to seeing what's next.
So how does it work? Well, imagine you blast off in a spaceship that could get close to the speed of light. For you, on that ship, time itself would actually slow down. After what feels like just a few years of travel, you could come back to an Earth that's decades or maybe even centuries older. You would have just taken a giant leap into the future.
And get this, it's been proven in the real world. Scientists put these hyper-accurate atomic clocks on jets, and they found they ran just a few nanoseconds slower than the exact same clocks on the ground. And astronauts on the International Space Station, they are literally aging slower than we are. After 6 months up there, they're about 0.005 seconds younger. I know, it's a minuscule effect, but it's real, and it proves time dilation actually happens.
But speed isn't the only thing that messes with time. Gravity has this powerful warping effect on its flow. To put it simply, the stronger the gravity, the slower time passes.
To really see this in action, just imagine hovering near the edge of a black hole, where gravity is just unbelievably immense. There, time would slow to a crawl. An hour spent there could equal years, maybe even centuries for the rest of the universe. It's another scientifically valid one-way trip to the future.
So a one-way trip to the future is scientifically on the table. Cool. But what about the Holy Grail? Going back in time? This is where we leave proven physics behind and start to wander into the truly speculative stuff.
The most popular idea for a path to the past is something called a wormhole. It's not a machine, but a hypothetical tunnel through the very fabric of space-time that could connect not just two different places, but two totally different moments in time.
The easiest way to picture this is to imagine spacetime is just a flat sheet of paper. A wormhole would be like folding that paper in half and punching a hole right through, creating this incredible shortcut. And that bridge, it could potentially connect this year to 100 years ago.
But, and this is a big but, there are some enormous catches. First off, we have absolutely zero evidence that wormholes actually exist. Second, our best theories say we'd need some bizarre stuff called exotic matter, stuff with negative energy just to prop the tunnel open. And finally, the amount of energy you'd need to create one? Astronomical. But let's say we could somehow figure all that out. Even then, traveling to the past opens up a whole new can of worms, logical paradoxes.
And that brings us to the most famous one of all, the grandfather paradox. Think about it. If you go back and stop your grandparents from ever meeting, you create this impossible logical knot. How could you exist to go back in time if you just erase the very reason for your own existence?
It's a classic catch-22, right? You start in the present, you travel to the past, you change a key event, and poof, you were never born. But wait,
If you were never born, how did you go back in time to make that change? It's just a perfect, maddening loop of contradiction.
Now, physicists have some pretty wild ideas to get around this. One is the many worlds theory, where changing the past doesn't actually change your past. Instead, you just branch off into a whole new parallel universe. Another idea is that timelines are self-healing, meaning the laws of physics themselves might just make it impossible to create a paradox, no matter how hard you try.
So, after all this talk about time dilation, wormholes, and paradoxes, where does that leave us? Let's take a step back and separate what we know from what we can only imagine.
In science fiction, you've got your DeLoreans, your TARDISes, easy trips to any time you want. In real science, traveling to the future through time dilation is a proven thing, even if it's wildly impractical right now. But traveling to the past, that is still purely in the realm of theory, all tangled up in these massive physical and logical problems we have no clue how to solve.
So yeah, you probably won't be building a time machine in your garage anytime soon. But the actual science of time has totally revolutionized how we see the universe. Time isn't some simple clock ticking away. It's a dynamic, flexible, and utterly fascinating dimension, full of possibilities we are just now beginning to explore.
So let's end with this. Let's just pretend for a second. If all the paradoxes and the physics just vanished, and you could step back into the past, what would you do? What's the one single moment you would want to see? It's a question that tells you a lot about your own life and the choices that make us who we are.